Woohoo! Welcome back. Tonight we're going to be talking about complex numbers. Yay! And in this first video, we're going to talk about where complex numbers came from. So to begin talking about that, we have to talk about a very interesting equation. The equation x squared plus 1 equals 0. So if we want to solve for x, we notice that, okay, we've got an equation and we've got a quadratic. So our first attempt would be to factor it. And then we realize, wait a minute, this is a sum of two squares, which doesn't factor at all. And then we look at it again, we see there are no greatest common factors. Well, technically 1 is the greatest common factor, so factoring out 1 won't help us. So then we say, okay, let's try using square roots. So to do square roots, I'm going to move the 1 by subtracting 1 from both sides. X squared equals -1. So I'm going to take the square root of x squared plus or minus the square root of -1. So I get x equals plus or minus radical -1, which is undefined. So what do we do? And the answer is that this is a question that mathematicians were asking hundreds of years ago. And in fact, a particular mathematician living in Italy, or who was Italian, don't know where they lived, suggested that maybe the answer is to come up with a new type of number. This was back in the 16th century, so this is quite a while ago. We're going to define a new number I, and I stands for imaginary in English, but I bet it stands for something slightly different in Italian. That would be my guess. But we all think of it, if you're speaking English while you're doing your math, we think of it as imaginary numbers. And we're going to define this number to be some number so that the square of I equals -1. Now, if you stop here, right there, if you've never looked at imaginary numbers, you're going to say, how is it possible that something squared equals a negative number? And I will remind you that negatives don't usually stick around, right? So if we take 1 squared, that's going to be 1 times 1, that's 1, right? Positive 1. But if we take -1 squared, that's going to be -1 times -1, which is also positive. So both of these are positive. So the fact that he's suggesting, hundreds of years ago, that there's some number which when you square it gives you a negative number, this is pretty revolutionary. And this is, I believe, when they came up with this idea, this was more of an idea where you're going to fit a pattern. You're going to say, okay, let's see if we can see what would happen if we define this number. So that's how we're going to proceed. If I squared is -1, then I squared plus 1 is -1 plus 1 is 0. And also, I would be, and granted, you wouldn't necessarily know this, but the decision was made to say that I equals radical -1, or the principal square root of -1, or some people would just say square root of -1. So basically, we're going to say, yes, this is undefined normally, but every now and again, we could expand our understanding of numbers and include this new number. Now, this is a little bit weird, and I granted it's a little bit weird. And if you have spent your whole life saying, well, negatives inside a square root are undefined, this is going to be really revolutionary. And I will let you know that it is revolutionary, it is really cool, but it is somewhat complicated. So what we're going to do is we're only going to use these numbers sometimes. Most of the time, we're going to stick with the real numbers that we've got already. But every now and again, we're going to go out and say, what about imaginary numbers? And look at the patterns that come up because of this. So let's look at some of what we would know. So what we would know if we have I is the principal square root of -1 or square root of -1 or positive square root of -1, whatever that is, then I squared by definition is -1. Now, then if I say, well, what's I cubed? Well, we can follow patterns. We're going to say, okay, we want exponents of imaginary numbers to follow the same rules. So that would be I times I squared, right? Because there are 3 of them, so it's one of them times I squared. But I squared is -1. So I cubed is the opposite of I, whatever I is. And then we say, okay, well then what's I to the 4th? I to the 4th would be I squared times I squared, right? There are 4 of them, so 2 of them and 2 of them. So that would be -1 times -1, which is +1, which is really interesting. Now, I to the 5th, that's I times I to the 4th. Well, we just found that I to the 4th is 1, so this is I times 1, and we've got something really interesting. We have got a new type of number that is cyclic or cyclical. It goes from I to -1, to the opposite of I, to 1, and then back to I. And I like to think of this as being on a circle. So, it's stuck. What does that mean? Well, you can set up your circle however you'd like, whatever makes the most sense. I usually put my I right here at the top, and I'm going to think of it like a clock, so I'm going to go clockwise. And I'm going to say here, I'm going to put I squared, which is defined to be the opposite of 1 or -1. Then we know that from up here, I cubed is the opposite of I. And then over here, I'm going to say I to the 4th is going to go over here, and we know that's equal to 1. And then the interesting thing is I to the 5th then goes right here. So I to the 5th is up here. And then where do you think I to the 6th is? You got it. I to the 6th is here. I to the 6th equals -1. I to the 7th equals the opposite of I. And I to the 8th equals 1. And then I to the 9th goes up here. I to the 10th, I to the 11th, and I to the 12th, etc., etc. And when you look at these numbers, you can see the patterns. For example, I to the 4th, I to the 8th, I to the 12th, these are all divisible by 4s, right? And then this is 2, 6, and 10, which don't have such an easy pattern, but we can see, wait a minute, once we get squared, then we just keep adding 4 to each one. 2 plus 4 is 6, 6 plus 4 is 10. Same thing down here. 3 plus 4 is 7, 7 plus 4 is 11. Now, you may think that you've never seen a number that behaves this way, but I would say actually you have, but you've seen a much simpler version. If we draw it with a circle, we could do that, but there are actually only 2 points. -1, and then here would be -1 squared, which if you square -1, you get +1. And if you do -1 cubed, it goes back up here. If we do -1 to the 4th, it's down here. So we do have another number that does this, but it doesn't really so much go around in a circle as it just flips back and forth. It's -1 if the exponent is odd, and it's +1 if the exponent is even. So we go bang, 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 like that. Rather than on the circle, going around and hitting all of these possibilities. So it's a really interesting number. It is really useful. There's a lot of math that uses it. We're going to use it in this class. There's actually a lot of use for it, and this always surprises me. Circuit design uses it, engineering uses it in a lot of ways, and there's a lot of theoretical uses for it. So the imaginary number actually comes up quite a lot. And so we're going to spend a little bit of time with it. And half of what we're going to do is going to be very, very, very theoretical. So like when we talk about this and we talk about going around in a cycle like this, and then some of it is going to be just computational. So for example, how do you actually use imaginary numbers? Well, to use imaginary numbers, basically what we're going to be using them for is to deal with negatives inside a square root. So if I have radical or square root of negative 144, there are two pieces to this. The minus inside, normally we would say undefined. This is not real. But if you're allowed to use imaginary numbers, which we are in this section, so you should always check, are we including not natural numbers. Always include natural numbers. It's very hard to count without them. If you're including imaginary numbers or complex numbers, then we're allowed to go further. So if we're with real numbers, we say this is undefined. But with complex numbers, negative 144 inside a radical is 12 because of the 144, like that. So it's whatever the square root would be without the minus, but then an I attached. So for example, in number 2, radical or square root of negative 1/4. Let me write that bigger if it's hard to see. The square root of 1/4 is 1/2. And the minus part is going to give us that I. So it's just like looking at square roots, but now we just attach an I. And again, this is if we're allowed to use complex numbers or imaginary numbers. And if you're told you're only working with real numbers, then you just have to say, oh, it's undefined. We can't go any further. So it's going to depend on what the setting is. Okay, then, I don't know why there's a number 1 there. That's very exciting, isn't it? There we go. What if we have something that doesn't simplify? So without the minus, that's the square root of 13. The square root of 13 is not a nice number, so we generally leave it inside the square root. And the answer is you're just going to write the radical and then give a little space so no one gets confused, and then put the I on the outside. So basically we just take that minus and rewrite it as the square root of negative 1. So basically what we're saying is this is 13 times negative 1. So it's radical 13 times radical negative 1. And that's how we get to that. Woohoo! Okay, so that was just the introduction. There's a lot more to say about complex numbers. So in the next video, we will expand this, practice some more, do some more work, and talk about how complex numbers interact with each other. Woohoo! So go get a snack, go get something to drink, and maybe take a break, have some fun, relax your eyes a bit, and then come on back here and we'll talk about more about complex numbers. Woohoo! Math on.